Do you panic every time you see a correlation matrix in SPSS? You're not alone. Most students ask, what does Pearson's R really mean? Is 0.6 strong or weak? What if your data violates normality? Can you still use Pearson's correlation? Ever wondered why two variables can have a significant correlation but still make no practical sense? In this video, we're not just running tests, we're solving real statistical problems. Stick with me to the end, and you'll not only understand your correlation results, you'll be able to explain them in your thesis or research article with confidence.
Today we'll see a correlation analysis on SPSS. Correlation analysis used to describe the strengths and direction of the linear relationships between two variables. And to do this correlation analysis, just click on Analyze, then Correlate. From a correlation, when you click that, you will have, I think, at least four options: bivariate, partial, distance, and canonical correlations. We will focus on the bivariate and the partial correlations. Bivariate will be selected if you want to measure the relationship between two continuous or ordinal variables, and partial correlation. It is selected when you want to measure the strength and direction of two variables while controlling for one or more additional variables. That means if you believe that there are control variables or confounding variables that may affect the relationship between two variables, you can select the partial and do the correlation analysis. We'll see that. Let's bring our variables, mental analysis variables, to this box. And after bringing the variables, here we have correlation coefficients for Pearson, Kendall, Spearman. We have checked the normality of our data and we decided it's normally distributed with several assumptions. And we are interested in Pearson, but we can also click Spearman if your data is not normally distributed. That means violates the assumption of normality. The other is test of significance, the two-tailed test or one-tailed test. That means if your hypothesis is interested in both the positive as well as the negative directions, you can choose the two-tailed test. Unless you have to choose one tailed test. For example, if your hypothesis says that individuals with higher level of anxiety will exhibit significantly higher level of depressive symptoms compared to those with lower anxiety levels. In this case, it's one-tailed, so you can choose one-tailed. Let's skip two-tailed. The other flag significant correlations that we need asterisks to be put there. Okay, and the other is options. When you click options, you will see one of the important aspect is missing values. The default is exclude cases pairwise, and the other is exclude cases listwise. You have to select either of them. If you select exclude cases pairwise, it only removes cases. That means observations with missing data. For example, if there is missing data in ADHD and another part it's okay, so it only removes that case from ADHD and holds it for other variables. But if you click on listwise, it removes that case from all of the others. even if the data is available, the value is available in other variables. So if you click exclude listwise, it removes the data. Let's see by example. For example, let's say our data set, and let's make, for example, uh, this missing. Our total sample size is 481. If you run this analysis with listwise, it will give you n 480. 480. That means it removes the whole row for the whole variables. But if you click on pairwise, if you click on pairwise, look, ADHD sample size is 481, anxiety is 481, self-esteem is 481, and all depression is 480. Let's interpret the results. To interpret the results, we will see n significance, that means the p-value and also percentage correlation, r. Let's begin from n. You have to check for n. If n is too low and there is a lot of missing data in your dataset, be sure whether you checked for exclude cases pairwise. And if n is okay with your normal sample size, that is good, because uh, n affects the significance level. If it's too low, it affects the p-value even if there is a correlation. The other is determining the direction of the relationship between the variables. For example, here there is ADHD and anxiety. It's positive 0.62. So the direction is positive. That means there is direct relationship. In some variables, the direction might be negative. That indicates the relationship is inverse. So that's one of the important point, whether the direction is positive or negative. The third and important part is the strength of relationship. How strong is the relationship between the variables? This the strength is falls between -1 and +1. Uh, when the numbers are closer to +1 as well as -1, that means there is strong relationship. And when they're closer to zero, they have weak relationship. While zero means there is no relationship, and one means there is perfect relationship. So the other numbers can be interpreted according to different research books. For example, according to Cohen, zero point 0.1 to 0.29 is small, 0.3 to 0.49 is medium, and 0.5 to 1 is large correlation or relationship between the variables. The other important part, but not included, mentioned here, is the coefficient of determination. That tells us about the variance between these two variables. So to get the coefficient of determinations, we have to square the R values. When you square the R values, you will get uh, the variance between the two variables. And the other important output value is p-value or significance level. Here in the bracket, it tells the test. Here it is two-tailed hypothesis testing used. According to your hypothesis, you can make it one test in the earlier section. So we selected two-tailed. So here, if the p-value is less than 0.05, it tells that there is a correlation and that's statistically significant. The strength of correlation is explained by the Pearson's correlation. R tells us the strength of correlation as well as the direction of correlation. And the p-value tells us whether that correlation is statistically significant or not. So a value is less than 0.05 means there is statistically significant correlation between the variables. Maybe one drawback with SPSS is it's not providing 95% confidence interval for R values that we have seen in JASP. If you remember from JASP gives p-value, sorry, 95% confidence interval for R percent R. Let's see some tips before running correlation. What things we have to check? The first thing is we have to check for our variable types. We have to check our variable should be continuous variables or ordinal variables by their nature. So check whether it's scale or ordinal. The other is check for any missing data, any missing values in your data set regarding that variables. Check that. And if there is a missing data, either remove those observations if there are few, or you can manage missing data. In spaces, there is how there's you can replace missing values. Here, there's an option. You can replace the missing values by serial mean of nearby points, median of nearby points, linear interpolation, and linear trend. How to choose that? It has its own science. If you are interested, I can create another video for that. So if the missing value is small in the data set, you can remove that observations or you can impute. And sometimes you might click listwise in the analysis, but if there are several missing values, it can distort your results. So avoid listwise deletions if many cases are lost. The other thing is normality issue. For Pearson's correlation, we strictly need normality assumption should be maintained. So you can use histograms, skewness and cortosis, or Kolmogorov-Smirnov and or Shapiro-Wilks test. So if there is a violation of normality assumptions, you can use Spearman correlation instead of the Pearson's correlation. The other thing, linearity assumptions. Linearity assumption is very important for the correlations because correlation assumes a linear relationship exists between the variables. So you can check that by scatter plot. Let's draw a scatter plot. For example, let's see anxiety and depression. Okay, great. Look, so this satisfies linearity assumptions. So we can check scatter plots for linear trends. Sometimes the trends might not be linear or it might be curvilinear. And on that case, correlations, the analyst will underestimate strengths of the correlation. Let's see common mistakes and errors. One of the errors is using Pearson's correlation with ordinal or categorical data. If our data is categorical, we have to use Spearman rather than Pearson's correlation. The other is ignoring outliers. Outliers can inflate or suppress correlations, so we have to identify them using box plot or z-scores. For example, let's see, let's change here some data and how we can inflate the correlation coefficient and distort the whole analysis. We included just in two observations, we inflated the values multiplied by 10. And let's see how it can affect our correlation. And you'll also see the scatter plot. Anxiety and depression. Look, the correlation coefficient jumped to 0.96, and it will affect others also. And also, let's see the scatter plot, how it distorts the whole matrix. Look in the scatter plot. Here it shows there is outliers. So outliers should always be checked in the data. Without outliers, let's see. I think let's yeah. Look, this is anxiety and depression data scatter plot before without outliers. So we have to check the outliers and we have to remove them. Outliers should be managed. Either it might be error due to data entry or whatever the case, they should be managed unless it distorts your analysis. The other is multicollinearity. Correlations of greater than 0.8, more than 80%, that means between predictors might suggest multicollinearity issues, and that should be also investigated and handled smoothly. The other final thing here it is how to report the correlation result. So here is our table. Usually variables will be listed in the row and in the columns. So you can write variables like this, full name, or here you can say anxiety, then 1 in a bracket. Then in place of anxiety, you can put just 1, 2, and 3 like that. I removed some variables. Normally, it will be reported like in this order: ADHD, anxiety, self-esteem, depression. Because this is just a placeholder. The values are empty for here, and also in the last column, the values are empty. So these are the values with full data. So I prepared like that. The other thing, how to narrate. Here I write a sample. So reporting tips. You have to always report sample size used in the correlations. It's important because you have seen last time, if the last sample size is larger, smaller correlation coefficients will be also significant. And if the sample size is very small, with the large correlation coefficient, significance might not be achieved. So for the readers, it will give clarity reporting the sample size. In my case, all of the variables has 481 sample size, so no need to include here. But if there is a variable number, you can include n here, n, n, if it's n is different. So the other reporting parties, including correlation coefficients and significance, these are the important part. So during the report, you have to include R and P values. Sometimes you may report a confidence interval here, or if it is available, you can put it here. That's okay. But mandatorily, you have to report R and P values. So that gives clarity for the readers.